Hi class. In today's video we're going to be looking at the repetition structures that are available to us in Java, or the so-called loops. We're going to start by looking at an example of a situation where a loop could come in handy. Let's assume we need to print a statement 100 times, this welcome to Java statement. It is true that you can do that with the help of just the print line statement by typing it 100 times in your code, but it's generally considered to be inconvenient and it's a poor programming practice. So in this situation we could be using a loop, and this is the first repetition structure that has been implemented in Java, the while loop. How do we do it? So the while loop is gonna look at an expression, evaluate if it's true or false, and if the expression is true, the body of the while loop will be executed. Okay, the body could be emptied. You could have just a single statement here, or you could have a whole bunch of statements. And for as long as that expression remains true, you're going to be executing the body of that while loop. The moment that expression becomes false, you end the loop and you continue with the next statement in your code. So if you look closely at the example here, we initialize the variable count to 0, and inside the while loop we print the welcome to Java statement, and then we increment the counter. When you come back up here in the header, you look at the count value again. If it's still less than 100, you go back inside the while loop and you print that statement again. And you're going to keep doing this until that expression becomes false, which in this case would be when count becomes equal to 100. So the moment count becomes 100, this expression will become false and you'll break out of the while loop. The general form of that while loop then is you have the keyword while, spelled in all lowercase letters. You have your Boolean expression. This could be just a single variable or a function call. Bottom line is it has to evaluate, the whole thing has to evaluate either true or false. You look at it, and then if it's true, you execute the statement or statements in the body. If it's false, you end the loop. Visually, this is what happens. It's a flowchart of the while loop. And if you want to trace it, if you want to play computer, let's see if we can do that with this example here. We initialize count again. It's an integer. Start with 0. And we tell the computer if count is still less than 2, I want you to print welcome to Java. So is count initially less than 2? It is, because it's 0. We come in here, we print welcome to Java. We increment it, becomes 1. That expression right there is still true, so we come back inside the body. We print another statement, welcome to Java. We increment it again. And as soon as it becomes equal to 2, that expression is no longer true, so we end the loop right there. And the output of the code that's shown up here is shown down here. We got just two strings, welcome to Java, displayed in the console. Another example, it's a little bit more complex. Okay, I already took the liberty of copying this and pasting it into my JGrasp editor. For this one to work, there was a statement that was asking the computer to read an integer from the keyboard. I need to import the scanner library. So it's an extra step, but it has to be there. Without it, the compiler will not be able to compile the code. So the scanner library is going to help me do the input part. Now, math random is something you haven't seen previously. It's part of the math library, and the math library is available to you by default. You don't have to explicitly import it. So all the math functions are available to you. We're going to see most of those, but today we're only concerned with this one right here. The random function is going to return a random value between 0.0 and 1.0. It could be equal to 0, but it cannot reach 1. So it's in the range 0.0 inclusive to 1.0 exclusive of the 1. So if we didn't really care about double values, but rather we wanted an integer within a certain range, the way to handle that is, you can see it right here, you can set a min and max by simply multiplying your random function by the max value you want to reach and then adding 1 to it. We haven't added 1 to this one here, so our range is going to be between 0 and 99. Okay. Alright, let's examine the code real quick before running this. So I import the library that I need. In here I generate a random value. By the way, this random value is not completely random. I don't know of a language that can generate a completely random value. They're called pseudo-random values because they're based on certain algorithms, but for all intents and purposes they are random to us, because every time you run this program you'll end up with what looks like a purely random value. So for all intents and purposes we're gonna just assume that this generates a random value. So we'll generate the random value, we'll make sure that it's in between 0 and 99. We're gonna keep that secret for now, that's stored in number, and we will invite the user to try and guess that value. Now, since they may not be able to guess it the first time, and since we want them to keep guessing until they actually guess the number, we accomplish that through the help of a while loop. So we're going to say, for as long as the guess of the user does not equal the random number that we have generated, we'll invite them to make another guess. And then we'll prompt them with an if-else statement to let them know whether they have now guessed it correctly, whether the number they've guessed is higher than the one that was generated or lower. And in this way we're nudging them towards the correct value. Let me run this. Click the little running guy. Alright, I don't know what the random value is. If I debug the program I'll be able to see it. That's not the purpose here though, so I'm just going to do something random. 45, the program tells me the guess is too low. 77, oh that's still too low. Okay, 89 is too high though, so I'm going to do 83, that's too high. 80, high. 79, 78, and that's the number that was generated by the program. I'm going to run this one more time real quick. See what other random number I'm going to get. 66 is too high. That one is too high too. Whoa. Alright. Oh my. Okay, I did not expect that. This time the random value that was generated was 0. And if I run it one more time, I'll end up with a third random value. So this is in our notes. It's a really good example of a situation where you could use the while loop. Alright, back to our presentation. Ending a loop with a sentinel value. So this is a new term for us, one that you need to be aware of. The sentinel value is just a value that helps you end the loop. So for example, in the situation here that we're seeing in this example, we want to end the while loop as soon as data becomes equal to 0. So we're going to be using the data variable as a flag, and for as long as data is something else other than a 0, we'll keep adding that to the sum, and we're going to keep repeating that and entering a new integer at the keyboard for as long as data is different than 0. The moment the user enters 0, this expression here will become false and will break out of the loop. So what's so special about this example? It's a demonstration of what they call a sentinel value. Please remember that term. We're going to keep using it in class. It's just a way for you to control the execution of a loop and to tell the computer when to stop the execution of a loop. A word of caution, sometimes if you're not careful, and this is a common pitfall, um, you may end up with a situation where you never actually reach your sentinel value. So if you're not careful and ensure that somehow you get closer and closer to your sentinel value, you may end up with a situation where you don't reach the sentinel value and you're stuck with an infinite loop. Now this example here is reminding you that if you want to use double, and to be honest with you, I've never seen this before in programming, so it's unlikely that you're going to be needing this, but you are allowed to use a double when you're comparing, when you're evaluating the expression here. And with doubles and floats, you have to be careful because they're not stored precisely the way that integers are. So keep that in mind. Okay, they're pretty close, but in certain situations they become just approximations, and you may get stuck in a situation that's really hard to catch. But like I said, this here is quite unusual. I haven't really never seen double values being used inside an expression like this one. Okay, the do while loops are another form of repetition structure in Java. They're virtually identical to the while loops. The exception is that you're always going to execute the body of your do while loop at least once. So the syntax is do, a pair of curly braces, while a certain expression is true, and you end that with a semicolon. In the while loops, you could have a situation where you never actually get inside the while loop body if the expression is initially false, whereas here you always execute the body of the loop at least once. And that is exactly what I just said. So with the while loops, you could be skipping the loop altogether depending on the value of the expression. With the do while loops, you execute the body at least once. And the third type of repetition structure in Java is the for loop. The for loop normally takes three different statements inside its header: the initialization part, the comparison part, and the part that updates the counter. Okay, let's see this in action. So you're going to do for, you initialize some counter variable. In this case, we declare and initialize I to be equal to 0. We tell the computer that we want this for loop to execute for as long as I is less than 5, and then every time you go to the next iteration, you want to increment the value of I. So if we play computer here and we follow the execution, we'll see that this particular for loop will be executed 5 times, and so we'll end up with 5 times the statement welcome to Java printed onto the console. Okay, it is important to understand that you could have in your initialization part, you could have multiple assignments. You don't have to have just a single one. So multiple expressions. That's also true for the part where you update any variables in the loop. Okay, you can have multiple statements there as well. And then in between those two, you do the comparison. It is also true that you don't have to have, you can just completely skip any one part, in which case the computer simply treats it as equal to true. So what you're seeing here is valid Java syntax, and it's equivalent to what you're seeing on the right side here. You have set up an infinite for loop here and an infinite while loop. So why would that be useful to you? Well, in here you're probably going to do something that at one point, let's say when you reach a certain sentinel value, is going to break out of the loop. So there's another keyword called break, which we're going to see in a second, that allows you to break out of any kind of loop. A common error that people make, I do that too, inadvertently place a semicolon at the end of the for header, similar to what we saw with the if statements. Please be careful. This is, I don't think the compiler, regardless of which one you're using, will complain. To the compiler, this looks like an empty for loop, so there's really no body to it and no statements to execute. Whereas down here, this is also valid. So just be careful. Make sure you don't add a semicolon at the end of a for header. The same way that you want to be careful with the if statement. And the same goes for the while loop. Okay, you don't want to kill the while loop right there where the header is. So this would be a problem. Your while header should be followed by usually a curly brace. With the do whiles though, we do need to have that final semicolon at the very end because it indicates where the do while ends. Which loop should you use? It turns out that you can translate any while loop into a for loop and vice versa. So basically they say you use the one that makes most sense to you, that makes your code easier to read and understand as far as you're concerned, the programmer. But as a rule of thumb, most programmers would probably go with a while loop when they don't know how many times the body of the loop will be executed, and they go for a for loop when they do know the number of repetitions. Okay, so we'll come across this topic again in the future when we start programming. Again, remember you can freely switch between these two. We should probably do that as an exercise in class as well. But generally, as a rule of thumb, we would be using for loops when we know the number of iterations, and a while loop otherwise. A word on nesting loops. This is perfectly legal, just like with the if-else statement. We had an if-else-if. We could nest ifs one inside another. Similarly here, we could nest loops one inside another. So what you're saying here is we're setting up an outer loop with a counter variable called I that goes from 1 to 9 inclusive, and then an inner loop with a counter variable called J that goes from 1 to 9 inclusive. And what will happen here is the inner loop is going to get executed completely before you move on to the iteration of the outer loop. Let's see if we can grab this and try it real quick. You may wish to pause the video here for a moment and see if you can guess what the output of this chunk of code is going to be once it's executed. And then you come back here and let's test it. Make sure I don't really need this part anymore. The name of my class is still the same. I've got, well, the indentation here is not really what it should be. Okay, now it's better. Whoops, there's a problem right there. I still need to close my main function. Alright, so let me see if I can compile this, make sure there are no problems with it, make the console screen a little bit bigger, and run it. And there's the end result. So this nested for loop is going to print the product of the two counters. Initially I is 1, so you see 1 times 1, 1 times 2, 1 times 3, and so on. Then I becomes 2, 2 times 1, 2 times 2, 2 times 3, and so on. And you keep going like this until the very last row here. You can see 9 times 1, 9 times 2, 9 times 3. The point or the purpose of this example is to make sure that you understand the inner loop gets completely executed before you move on to the outer loop. And we're going to be using nested for loops in our exercises as well, so we get more opportunities to play with this. Alright, the break and continue are the two other keywords that people use with loops. They're not used as often, but they're still there. They're in your toolbox, and there are situations where they could become really useful. Let's see how they work. The break keyword is a statement that allows you to break out of a loop. In this example here, we have a while loop, and we got an if statement at the end that says if the sum ever becomes greater than or equal to 100, I don't want you to do this anymore. Break out of the while loop and end it. Okay. The continue command is going to force the loop to go on to the next iteration. So it's kind of like a go-to statement. It tells the compiler, do not execute any more commands in the body of this loop. Just go back to the header and move on to the next iteration. So quite like a go-to statement. Let's see if we can, but just by looking at this, decipher what's going to happen here. So we initialize number to 0, and this is a value that we keep incrementing by 1, and then adding it to the sum. So we're keeping track of the sum of all the numbers starting at 1 and then going all the way to 19. If number becomes equal to 20, we never add that. So yeah, we start with 1 and we go to 19. However, we got an if statement down here that says if number is ever equal to 10 or 11, do not add those to the overall sum. Okay, so the end result here is going to be the sum of all the integers from 1 to 19, excluding 10 and 11. Okay. All right. And that wraps up our discussion on repetition structures in Java. Thank you very much for watching.